Hi everyone, in this video we're going to be looking at trigonomic ratios in right angle triangles. Before we get started by looking at examples, we're first going to explain what the three primary trigonomic ratios are and how to get them given a right angle triangle. So let's look at this triangle down here. We know it's a right angle triangle because one of the sides is 90 degrees. I'm going to label that triangle as triangle ABC. And the other things we can label are the sides. Now to do that, I'm going to pick angle A to be theta, or my reference angle. The longest side is always known as the hypotenuse. The side touching the angle is known as the adjacent, and the side opposite the angle is known as the opposite. Now, what are our three primary trigonomic ratios? These can be memorized really simply using the acronym SOHCAHTOA. So SOH, CAH, and TOA. What this stands for is sine of our reference angle theta is equal to opposite divided by hypotenuse. Cos of our angle theta is equal to adjacent divided by hypotenuse. And tan of our angle theta is equal to opposite over adjacent. Now that we know that, we are able to solve any right angle triangle or get the three primary ratios of any right angle triangle if we know the three sides. So let's go down and look at an example of this. In this example, I'm going to choose Z as my theta, and I'm going to start by labeling the sides. So 21 will be my opposite side. 28, since it's the side touching the angle, will be my adjacent side. And the longest one is always the hypotenuse. Now we're trying to get our three primary trigonomic ratios for this, which means we're going to use SOHCAHTOA. So SOH, CAH, and TOA. So remember, let's start with sine. Sine is equal to opposite over hypotenuse. In this case, opposite side is 21, and the hypotenuse is 35. Simplify this by thinking about what these numbers are both divisible by. In this case, they're both divisible by 7. 21 divided by 7 is equal to 3. 35 divided by 7 is equal to 5. Then we can move on to cos. Cos of our reference angle is equal to adjacent divided by hypotenuse. Our adjacent side is 28. Our hypotenuse again is 35. Now once again, these are both divisible by 7. 28 divided by 7 is equal to 4. 35 divided by 7 is equal to 5. Lastly, we have tan. So tan of theta would be equal to opposite over adjacent. Our opposite side is 21, and our adjacent side is 28. These are once again both divisible by 7. So this one reduces to 3 over 4. Let's look at one more example of this. So in this example, let's say we're working with angle C. I'm going to call that theta. That would make our opposite side the 14th, the adjacent side to be our 48, and our hypotenuse to be the longest side opposite of the right angle, which is the 50. If we look at SOHCAHTOA, we know that sine of our angle theta would be equal to opposite over hypotenuse. So opposite is 14, and our hypotenuse is 50. These numbers can be reduced because they are both divisible by 2. So this fraction is going to reduce to 7/25. Then we get to cos. Cos of our angle theta would be equal to the adjacent side, which is 48, divided by the hypotenuse side, which is 50. These, once again, are both divisible by 2. 48 divided by 2 gives you 24. 50 divided by 2 gives you 25. Then we get to tan. Tan of theta should be equal to opposite over adjacent. Our opposite side is 14. Our adjacent side is 48. Once again, these numbers are both divisible by 2. When we divide 14 by 2, we get 7. When we divide 48 by 2, we get 24. And that would be the 3 primary trigonometric ratios for that triangle.